بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. Hello everyone and welcome to our video series Teach Arduino at Rabii Hajoui YouTube channel. In today's video, I'm going to show you how to build an Arduino door alarm using an ultrasonic sensor. But before this, I'm going to introduce you to an amazing teacher from the Philippines. She's doing an amazing work with her students, and she's our global partner for education. Her name is Irene Nicholas. That's why I named this video after her. So the name of this project is Irene Project. The Irene Project will help you to prevent burglars from entering your house. Here is an illustration for the Irene Project. For example, if a burglar succeeded to enter or to open the door of your house, the alarm will go on. So, please don't forget to subscribe, like, and share our YouTube channel. So we need for this project Arduino Uno board, a USB cable, a breadboard, a red LED with 220 ohm resistor to protect it, and active piezo buzzer, an HCSR04 ultrasonic sensor, and of course jumper wires. Now let's connect our circuits, which is in the middle of the screen. So the first thing that we're going to do, as usual, is to connect, as you can see here, is to connect the 5 volts to the red line and to connect the ground GND to the blue line here. So as you can see here, we have 3 pins: ground, echo, trig, and VCC. So we're going to connect it like this way. Okay, now the VCC is going to be connected to the 5 volts, the red line, and the ground GND. So here the GND is going to be connected to the ground, the blue line here. So we have now the trigger and the echo. Let's see, in our circuits we have the trigger is connected to pin number 4. The trigger is connected to pin number 4, so from the screen, pin number 4, and the echo is connected to pin number 3. The echo is connected to pin number 3. We finished with our ultrasonic sensor. Now let's go to connect our red LED. As usual, the red LED has 2 legs. The first, so the shorter is going to be connected to ground, and the other longer leg is going to be connected to one of these pins. So let's put it like this. Okay. Now the shorter is going to be connected through the 220 ohm resistor to the ground, like this. Okay, and the longer is going to be connected to pin number 2, like this, connected to pin number 2. Now let's connect the piezo buzzer, the active piezo buzzer. So here we have also 2 legs. So the shorter leg is going to be connected to the ground, and the longer leg is going to be connected. So let's put the piezo buzzer here behind the ultrasonic. So the shorter leg is going to be connected to the blue line, and the longer leg is going to be connected to one of these pins. Let's choose pin number 5. So here is our circuits as you can see it. Before going on, we need to know how does the ultrasonic sensor work. As you can see, the ultrasonic sensor consists of 2 eyes. One is used to transmit the signal and the other to receive it. The time that it takes for the signal to be transmitted and received is calculated by the microcontroller. Now we know the time, we know the speed of the signal, the sound. We can calculate the distance. So we are going to use this formula. Distance equals time multiplied by speed of sound. The speed of sound is known. It is 343 meters per second. We are going to transmit it to microsecond because all the microcontrollers would work with microseconds, which is 0.0343 centimeter per microsecond. You know that the time is calculated for the signal to be transmitted, hitting the object and going back. We need only to measure the distance between the ultrasonic sensor and the object. That's why we need to divide this equation by 2. Now let's see our Arduino code. In order to transmit the signal, we are going to put the trigger pin as high. I mean by the trigger pin is the transmitter. In order to transmit the ultrasonic signal, and after that we need to wait for 10 microseconds and put the trigger or the transmitter as low. In order to receive the signal, we put time equals pulse in, echo pin, it means the receiver as high, and the distance equals time multiplied by 0.0343 divided by 2. Now, after knowing how the ultrasonic sensor works, let's code our circuits by clicking on the Arduino IDE. So here is our Arduino IDE. The first thing that we should do is to define the variables. The first variable is the type integer, is the transmitter, the trigger, trig pin, and we connected the trig pin to pin number 2 on Arduino here. After that, Control C, Control V, the echo pin. We have the echo pin. We connected the echo pin on pin number 3 on Arduino. Pin number 3. Control V, and also we have the buzzer pin. Buzzer pin. We connected the buzzer here, as you can see, to pin number 4. Pin number 4. Control V, and also we have the red LED pin or red light pin. Red light pin. We connected the red light pin to pin number 5. We need also another variable for the ultrasonic wave time. Int ultrasonic wave time, and another variable, the type int, which is the distance. Don't forget the semicolon. And we need to declare a wait time of 250 milliseconds. Now we finished declaring our variables. Let's go to the void setup by using the pin mode function. Pin mode. Okay, the first is the trigger pin. The trigger pin, is it an output or input? Yes, good. The trigger is emitting the wave, so it's an output. Output. And let's go to Control C, Control V. Now the echo pin, Control C, Control V. The echo pin is an input. The transmitter and the receptor, it will reset the wave. It's an input. Okay, and let's copy these two lines, Control C and Control V. Now we have the buzzer pin, Control C, Control V. The buzzer pin is an output because Arduino will give it 5 volts in order to go to declare the alarm. The alarm will go on. And the red light pin, Control C, Control V, it's an output, also an output. And we need to declare the serial dot begin and set the speed of communication to 9600 semicolon. Now we've finished with our void setup. Let's go to the void loop here. So the first thing that we should do is to put the trigger as high in order to emit the ultrasonic wave by using the digital write function. So digital writes, okay, the trig pin, the trigger, Control V, we need to put it as high. Okay, semicolon. And we need to wait for 10 microseconds. Delay microseconds. Okay, 10 microseconds. And we need to put it off. Control C and Control V by using low here. Okay, now we need to declare the time, Control V, equals we're going to use a function that is going to calculate the time of the wave. For example, when the door is open, here you can see the transmitter will transmit the wave, and when it will intercept the door, it will go back. Our microcontroller will determine or will calculate the time of the transmission and the reception. We're going to use the pulse in function. Pulse in function, and the first element of the pulse in is the echo pin. Control C, Control V, comma, high. Okay. Now, we know the time, we know the speed of the sound or the ultrasonic wave. We can determine the distance. We have our distance, Control C, Control V, equals what? Equals the ultrasonic wave time multiplied by the speed of sound, which is 0.0343 divided by 2 semicolon. Now we need to put a condition here. If what? If the distance, Control C, Control V, is less or equal 20 centimeters. Now, what are we going to do in this case? For example, here, the distance is more than 20 centimeters. So the door is closed. When the thief will open the door, the distance will be less than 20 centimeters, and in this case we need to put on the alarm and the red LED. In this case, you can see our door is open here. So what are we going to do? We are going to write a message, serial dot print the thief opened the door. Okay, we're going to put space and semicolon. We're going to copy this line and paste it. So here we are going to print also distance. I need to put this sign here. Distance, okay, equal Control V. We need to print and add ln. Now it will goes by adding line, it will goes to the next line, and we are going to print the variable distance. Control V. So here and we need to put what? We need to put the red LED on by using the digital write function. Control C, Control V. We're going to go to our variable red light pin, and we need to put it high, and also we need to put high the buzzer. Control V. Let's go to the buzzer pin. Control C and Control V. So now this is when the door is opened and the thief opened the door. We're going to copy this by Control C and Control V. Now in the else case, the else, it means that else, okay, it means that the distance, in the else case, it means that the distance is more than 20 centimeters. Now we are going to print the door is secured. The door is secured. Okay, we need to print the distance, and we need to put the red light pin as low and the buzzer pin as low. Here is our code. Now let's check if we have some errors. We are going to name this program. We're going to put it in the desktop and name it door alarm. Okay, and we are going to save it. Now as you can see here, it's compiling, it searches for any errors. Let's hope that we don't have any error here. Done compiling, it means that it's good. Now you need to connect the USB cable to the laptop. The USB is connected now. Let's upload our code. Now our code goes from our laptop to Arduino here. Okay, done uploading. Done uploading. Let's open the serial monitor here. So as you can see, the message is door is secured. Now you can see the door is secured and the distance is 61 centimeters. It means that no one opened the door. Now let's test. Now the thief will open the door and you can see, yes, good job. Now you can see that the distance is 3 centimeters and the door is open. Good. Our alarm system works. Great. Thank you for your attention. Please, if you like this video, subscribe, like, and share Rabii Hajoui YouTube channel.